All right, we're going to try day 4 again. So here we go. The first part is looking at page 6 of the notes. A monatomic ion is a charged particle containing only one atom. So that's what we looked at on day 1. Okay, and then a polyatomic is a charged particle containing more than one atom. So you have your list here that I gave you in class yesterday. Polyatomic, more than one capital letter ion, right? All of these have more than one capital letter. Now, the one thing, though, about writing formulas, just like how we've been doing them for binary, is that we are going to look at the crisscross reduce method. But the thing about polyatomics, since it's more than one capital letter, we might have to use parentheses. So there are two conditions that you need to meet to know if you need parentheses or not. There first has to be a polyatomic ion present. In other words, there has to be more than one capital letter. And you need to cross, right? When you do the crisscross method, right? The number that you cross is 2 or greater for the polyatomic ion. And so we're going to look at examples here. Here, right, we have 1 plus, 1 minus. NO3, 1 minus is a polyatomic. These cancel, so I just rewrite NaNO3, right? This is a polyatomic, but since I didn't cross a 2 or greater, no parentheses are needed. Here, this one has a 2 plus, this is 1 minus, right? When I cross, because they don't cancel, I rewrite everything here first, right? When I cross, I put a 2 here. I do need parentheses here because it's polyatomic, more than one capital letter, and I cross a 2 or greater. Here I have 1, here I have 2. Rewrite everything that's with the symbols NH4, SO4. This is important so you don't accidentally forget those numbers that are already there, right? Cross, 2 here, 1 is understood. Do I need parentheses? Well, both of them are polyatomics. I do need parentheses here because it's a polyatomic, right? And I cross a 2 or greater. Here, right? 1 plus, 1 minus, NaOH, leave a little space, right? These just cancel. No parentheses are needed because this is a polyatomic, but I don't need more than one. Here I have CO2 plus and OH 1 minus. So I have CO and then OH, right? These don't cancel. 1 and 2, I cross the 2 here. Now a lot of students don't recognize that you need parentheses here because this one would look like 42 H's, this one would look like 32 O's if I didn't put parentheses. But this has 2 capital letters, and I crossed a 2 or greater, so I definitely need parentheses. I would make sure I know that for the test and also for the lab. Last one here to look at for knowing when we need parentheses, Al3 plus and CO3 2 minus. So I have Al and then CO3. The 3 and the 2 can't be reduced, so I have 2 and 3. Now, I don't need parentheses here because this is not a polyatomic. This is just 1 capital letter. Here, 2 capital letters, and I cross a 2 or higher, so I put parentheses there. All right, now we're going to practice writing formulas from names. Ammonium carbonate. So you have to know your ions. So I'm going to go ahead first and just write the ions. So NH4, 1 plus, carbonate is CO3, 2 minus. Remember, if you need to double check, you should be looking at this list. Aluminum, that comes straight from the periodic table. That's in group 3, so that's Al3 plus. Phosphate, PO4, 3 minus. Once again, we're only writing the ions. Now what we're going to do is write the formula. So remember, I highlight the numeric part of the charge, rewrite everything else. 1 and 2 do not cancel, so I have to put a 2 here. I need parentheses because it's more than 1 capital letter. Here, 3 plus 3 minus cancels, So that just gives me AlPO4. Now we're looking at the next one. Magnesium is Mg2+. Sulfite is SO3 2-. These cancel or can be reduced, right? So that's just going to be MgSO3. Here, aluminum is Al3+. Sulfide is S2- from the periodic table. 3 and 2 are highlighted. Al, leave a little space, S, right? Doesn't cancel, so, or can't reduce, right? So 2, 3. Do I need parentheses? No, because I don't have more than one capital letter. Here, Ca2+, OH1-, 2 here, 1 here, right? So rewrite the symbols with any subscripts that are naturally there with the polyatomic ions. Cross 2 here, more than one capital letter, yes, and I crossed a 2 or higher. Remember, know how to do something like that. Calcium is Ca2+ from the periodic table, Cl1-. This is review of day 3 because neither one of these are diatomic. I'm sorry, neither one of these are polyatomics, so it's just CaCl2. These two are review of day 3, which is what we did yesterday. All right, now we're on this side looking at transition metals. When it comes to transition metals, the valence number of transition metals may vary. So what does that mean? When I'm looking at my periodic table may have metals that have more than one charge. If I look at Fe, right, it's Fe2+, Fe3+. Nickel is 2+, 3+. So far, we've been looking at metals that only have one charge. When they only have one charge, you don't put a Roman numeral. But when these middle group ones or these post-transition, I have to put Roman numerals. So as a result, a single transition metal may have more than one charge, which is the oxidation number. And so we have to use Roman numerals. So what are our Roman numerals? 1, 2, 3, 5 looks like this. So 4 looks like this. Not that, okay? 6, 7, 8, and 10 looks like this. So 9 is this, okay? So if I want to show Fe2+, right, it's going to be a Roman numeral 2. This one's going to be Roman numeral 3. So the name of this is going to be iron Roman numeral 2, and this one's iron Roman numeral 3, right? It's kind of like if I have two people with the same name in the classroom, I need to be able to distinguish. Let's say I have two Jeffs, right? Jeff A, Jeff B, right? I'm going to make sure that I represent how they are different, okay? But some of the post-transition metals, so not just transition metals, but post-transition elements, right? Like these two here have more than one charge, and that would be Sn2+, Sn4+. Over here, Pb2+, Pb4+. And because those have more than one charge, we have to use Roman numerals. Now, of course, to make things even more complicated, there are some transition metals that only have one possible charge. Something like silver, Ag1+, and zinc, 2+, and cadmium, 2+, these three, right? So let's look at it on our periodic table here. Ag is 1+, Cd is 2+, zinc is 2+. They only have one possible charge. If they only have one possible charge, we do not put Roman numerals, just like how we didn't for these, right? Like NaCl is our concrete example. We don't put Na Roman numeral, or sodium, we don't say sodium Roman numeral 1 chloride, okay? So if it only has one charge, and remember, you get to use this type of periodic table on the test and on your homework, you never put Roman numerals. So now we practice. So if I have iron Roman numeral 3 nitrate, what that means is that this is Fe3+. So that's Fe3+, and nitrate is NO3 1-. So highlight the numeric part of the charge, rewrite everything, right? So I have FeNO3 cross. 1 is understood. I have to put parentheses because it's a polyatomic with more than one capital letter, and I cross to 2 or greater. Magnesium oxide. Magnesium is Mg2 plus, oxide is O2 minus. This is review of binary, right? That just cancels. MgO. Copper 1 chloride is Cu 1 plus, chloride is Cl1 minus. Those cancel, Cu, Cl. Here I have tin 4 oxide, which is Sn4 plus, oxide is O2 minus. Highlight the charges, SNO. I can see that these can be reduced though. So this is 2, 1, and then I cross. So 1, 2, SNO2. Know how to do one like this for the test. All right, now we're going to look at putting this all together. You're going to name the cation first, the anion second. If an element has more than one charge state, you're going to use Roman numerals. So let's think about this, right? If it's a metal, right, I have to make sure I look at, does it have more than one charge? If it doesn't have more than one charge, no Roman numerals. If it's a transition metal or a post-transition metal that has more than one charge, I have to use Roman numerals, okay? If it's a non-metal, right, I just name it by changing the second part of the name to "ide." Now, probably the most challenging part of nomenclature in this section would be these types of problems. So, why is this challenging? Because we're going from the formula to the name. And when you go from formula to the name, you have to recognize that if it's a transition metal, you may need Roman numerals. And I need to know if it's a transition metal with more than one charge. So highlight any transition or post-transition metals with more than one charge. These ions need a Roman numeral. Okay, so I like to just look at the periodic table. So when I'm going from formula to name, right, highlight cations that need Roman numerals. Rn is Roman numerals, okay? So I'm going to look for Cu, right? Here, Cu. Right here, it can be 1 plus or 2 plus. So that means that I need Roman numerals in the name. So it can be, like we said, Cu 1 plus, or it can be Cu 2 plus, and I have to figure out which one it is. Same thing here, right? It's another Cu. So it's either Cu 1 plus or Cu 2 plus, and we're going to figure it out, okay? But I have to have Roman numerals. Pb. Let's look at Pb. Pb is here. Can be 2 plus or 4 plus. So I need Roman numerals. Pb 2 plus, or it can be Pb 4 plus. Same thing here, because this is another Pb. Na, right? I look for Na. That's an alkali metal, only one charge. No Roman numerals. Cr, chromium, right here, can be 2 plus, 3 plus, or 6 plus. Cr can be 2 plus, Cr 3 plus, Cr 6 plus. Now, do you have to go through and try to figure out which one it is for each one? Some of them might be easier than others to figure out. I try to minimize making mistakes, right? And the best way to do that when it comes to nomenclature is to make sure that you look at all possibilities. So I know that this is copper, so this is copper, but I don't know if it's 1 plus or 2 plus. So I have to look at the anion. According to this, right, you may have to use a charge and the number of anions to figure out what the charge of the cation is in. Well, this here, right, is the polyatomic nitrate, which is NO3 minus. So this is NO3 minus. Well, it can't be this one because this one would be 1 to 1, so it'd be CuNO3. So it's not that one. It must be this one, because when I reduce crisscross, I get this formula. So it's copper 2. So it's Roman numeral 2. NO3 is nitrate. All right. Next one. This is O, right? But this comes from the periodic table. O is 2-. So this is O2-. It's not this one because then the formula would be PbO. Let's see if it's this one, right? This one's tricky. Why? Because if I look at my charges, right, I have to reduce these to 1, and that's going to give me PbO2. So it was this one, the original of Pb4+. So this is going to be lead, Roman numeral 4, and then O is oxide. Let's do this one since we're looking at Pb again. Here, this is chromate, CrO4 2-. That's this one here. Here's that one, right? 1 to 1, it'd be PbCrO4, so it's not that one. It must be this one. So this is lead, Roman numeral 4, and then CrO4 is chromate. Now we're looking at this one. I know that this is copper, but I have to figure out if it's 1 or 2. If SO4 is 2-, when I reduce crisscross this, it would be Cu2SO4, so it's not this one. It must be this one. So that means I have to put a Roman numeral 2. Sulfate is the name of SO4 2-. NaBr, that, I just look at the periodic table. Na is sodium, Br is bromine, but the ending changes to bromide. Last one here, we have Cr2SO3 So SO3 is 2-, right? So let's see which one it is. If I reduce crisscross, this is SrO3. So it's not that one because I need it to be this formula. When I cross these though, because they don't cancel, I have Cr2, SO3, 3. That one's it. So that is chromium, Roman numeral 3, sulfite. Okay? And that concludes our notes. But now what we want to do is look at our homework. So our homework is day 3. And I want to do the example with you and then one on each section in the back. So when it comes to this page, right, we are looking at what are the possible answers. Predict the charge of the ion. So chromium and Cr2O3. So I look at my periodic table, and in my periodic table, it tells me that chromium can be 2+, 3+, or 6+. So Cr can be 2+, 3+, or 6+. So now what I have to do is recognize that this is oxide. So if I have Cr2+ with O2-, that would be CrO, so it's not 2+. I'm going to try Cr3+. If it's Cr3+ and O2-, reduce crisscross, that's going to be Cr2O3. That one's it. So the answer is Cr3+. Once you figure out which one it is, you don't have to try all of them, but it just helps, right, to do that process of elimination. All right, let's look at the back of 7.3. Over here, write the formula for the following compounds. Hint, it helps to write the ions first, and you have to anyways. Iron, Roman numeral 3, is Fe3+. Cyanide is C, capital N, 1-. Remember, highlight the charges, especially just the numeric part, right? Nothing can cancel. Rewrite the symbols and any subscripts that go with the polyatomic. Cross. 1, 3. Do I need parentheses? Yes, because it's more than one capital letter and I cross the 3 or greater. Now, I want to go through just one of these down here, right? Write the correct name for each of the following. Remember, this gets tricky because something like iron has more than one charge. So it's going to help to highlight any of the transition metals that have more than one charge. So I'm only going to do one with you, right? So I look at FeCrO4. Well, I look at Fe and it can have more than one charge. So I highlight that and I know that I have to put Roman numerals. So I look at my periodic table. Fe can be 2+ or 3+. So my job is to figure out what it is. How do I figure it out? I look at the anion, what it's paired with, which is chromate, right here, which is CrO4 2-. So I can see that if I reduce crisscross, this will give me FeCrO4, so it's that one. So the name is iron, Roman numeral 2, and CrO4 2- is chromate. So you need to complete this worksheet and upload it before 8 a.m. the next day.